Okay, so now we're going to have a look at geometric. Geometric progression. Okay, what is the difference between geometric and arithmetic? What's geometric? Yeah, common ratio. So if you have a sequence like, let's say, 3, 6, 12, 24, what's happening each time? Multiplying by 2, yeah. So R is the common ratio, and in this case it is a 2. And the A, again, is the first term, and in this case it's 3. Okay, so just like the last lesson, let's have a look at some formulas. So, the first term is obviously A. The second term would be A multiplied by OR. The third term would be A multiplied by OR multiplied by OR again. So that's AOR squared. And the fourth term would be then AOR cubed. So you could probably figure out the formula here. The nth term would be AOR power n minus 1 then. That is our first formula, and we'll have a look at some examples now. Okay, you can write that down, please. Okay, you got that? Not yet. Yeah, okay. So let's have a look at some examples. First example, just like the last lesson, I want the A and the OR this time. So what's the A? And the OR? Minus 2. Yeah? Yeah? Okay, fine. 10, 20, oh sorry, minus 4, minus 8, minus 16. I want the formula here. So UN is A times OR n minus 1. Now if you like, you can clean this up a little bit, because this will be minus 4 times 2 power n over 2, which would be minus 2 times 2 power n. And what could this be simplified to? I know we haven't done the rules yet, but 2 power, so you could simplify this to 2 power n plus 1. Yeah? Yeah, yeah. That's okay. You can pull the minus outside. Yeah? But don't worry about that. That's not so important for today. That will be a later lesson, okay? It's not a big deal. Right, next example. How many terms are in this sequence? Okay, let's have a look. Well, how did we do it in the last lesson? Yeah, you put minus 243 equal to UN. Yeah? So that's minus 243 equals A, or n minus 1. What's the or here? Is it minus 2? No, I don't think so. Minus 3. Yeah. Now I'm sure minus 3 divides into minus 243. It'll be 81? Okay. 80. Oh yeah. 81 equals minus 3 power n minus 1. There's something I know about n minus 1, because this is a negative and this is a positive. Does anyone spot something I can know about n minus 1? Oh, but I just mean the n minus 1, there's something I know about it. It is n minus 1. Even or not even? N minus 1 is even. Well, it has to be even because you have a negative to... Yeah. So you actually know that n minus 1 must be an even number. Is the only explanation for how the minus disappears on the left. So if n minus 1 is even, then what do you know about n? N must be an odd number. Yeah. But anyways, that's not necessary to know that. Okay, so is that 4 minus 3 brackets power 4 makes 81? Yeah. Now, why did I do that? What's the advantage of doing that? Yeah, you can see that on the top, minus 3 power 4 equals minus 3 power n minus 1. So therefore, you must have this, which means n is 5. Okay, that's getting harder now, if you can write that down. Yeah? You got that? Not yet. Yeah? Yeah? Okay. Next example. I tell you that the third term is 8 and the 8th term is 256. Okay? You can see what's going to happen again. What type of problem will this be? Simultaneous, won't it? So the first one, U8, is A or power... What power? U8? 7. Good. And then the second one is A or... Is okay? Okay? Yeah. Now, what do I do next? I need to divide them. Dividing is the best thing to do here. You can divide the two lines. So if I divide them, I get this. Left over left equals right over right. And on the left, what cancels? Well, the a's cancel. And what does the or become? It's or power 5. And 256 divided by 8 then. 32. Okay, 32 is 2 power 5. So then, what's the or? Is it possible that the or could be minus 2? No. Because the odd power here would make it a minus 32, which is no good. So, or can only be 2. I can get the a, I think, by just subbing it into this second equation. a times 4 equals 8. Yeah, so it's also 2 actually. A is 2 as well. Okay, write that example down. You got that? You got that, guys? Yeah. Yeah. Okay. Let's continue. So, scrolling down. So now we're on to the sum formula. So once again we have a or squared, and what's the last term? Yeah. So I want to calculate a formula for Sn, which will be a plus a or squared, etc., until the nth term, which is a or n minus 1. Yeah. Does anyone know the trick here for this proof? And it's not like the last one. You don't write it backwards. No? No ideas? Some idea? What do you think? No idea? No. Maybe. Multiply by what though? No, not this. Okay, so the trick here is you multiply by or. So if you multiply all these by or, what does the first one become? A or. Yeah, you can see what's happening. A or cubed. And just be careful, what would be the last one? Mm-hmm. A R N. Because remember, this is like or n over or. So it cancels. Yeah. Now, what I do next, I combine these two by minus. So I have Sn minus or Sn. Now, you notice that on the top you have an a or, and on the bottom you have an a or, so when you minus, they cancel. And here you have an a or squared, and here you have an a or squared, they cancel. And likewise you'll have an a or cubed and an a or cubed, they'll cancel. Can you see how the diagonals cancel? So this will cancel with the one before it. There's actually only two terms which don't have a partner to cancel. The first one here, and the last one here. So this will be equal to a minus a or m. What's in common on the left? Sn. What's uncommon? What is common on the right? So Sn equals a 1 minus or n over 1 minus or. And I should put the extra requirement just to say that or cannot equal, any ideas? 1. Now, I think I know what you're thinking. You're thinking, isn't there another formula that has or n minus 1 over or minus 1? You're thinking that. I know. This is an awkward way to find out that I'm secretly an X-man and I can read your mind. Yeah. Yeah, no, you don't need to say it. I know. So, some of you also are thinking that there's a second formula here, that you say Sn equals a 1 minus or n over 1 minus or Sn equals a or n minus 1 over or minus 1. Yeah, I know. I know what you're thinking. So, I don't know why books have the second formula in it, because it's the same as the first one. All that you've done is multiply the top and bottom by minus 1. And I think the books usually say something like, oh, you use this when or is less than 1 or something like that. And then this one you use when or is more than 1. Yeah, I don't know. It's not necessary. It's completely unnecessary. Everything is contained in just the one formula. It's enough for me to write this and just say or is not 1. It could be anything else. Okay? All right, write this one down. And then we'll look at some examples. Okay. You got that? Yeah? Right, let's look at some examples. Calculate S6. 1 plus 2 plus 4 plus ... 32. So S6 would be A. What's A? 1. 1 minus or. What's or? 2. Power n? 6 over 1 minus 2, isn't it? 2, 4, 8, 16, 32. Is this 63? What is it? Is it 63? Yeah. Okay, the next one is I want the formula. Okay, so what's the formula here? Sn equals A. What's A? Minus 3. 1 minus or. What's or? Minus 3. N over 1 minus or again. Yeah? We don't need to clean it up. I just want the formula, so we can just leave it like that. Obviously, 1 minus 3 is 4, so if you want, you can at least just say this. Like that. Okay. Next one. I want the sum here. Up to 192. A? Minus 3 or 2 and n. We need to figure it out. So, we have A or n minus 1 equals minus 192. 3 goes into 192. What's that? 8, 64. Yeah? No, 64 is 2, 4, 8, 16, 2 power 6, isn't it? So then n minus 1 equals 6, so n equals 7. So now we can finish and get the sum. S7 is A, 1 minus or power n over 1 minus or 123 times 3 minus 369. Is that it? Yeah. No, I don't have a calculator. So not minus 369? Wait, I said 381. And I said, is it not 381? And, okay, I wrote. It's 381?
Yeah.
You must be sending me some interference. I'm not thinking clearly. Okay, 2 more examples. Okay, now on to a tough one here. The 9th term is 256, and the sum of the first 3 terms is 3. Okay? Simultaneous again, but a very tricky one. Let's have a look at it. Right, on the left I get a or power 8. And on the right I get a 1 minus or cubed, isn't that right? Over 1 minus or. And that is equal to 3. Yeah? Now, this is a bit, okay, this is not great, but it's not too bad. This is a bit of a mess here, isn't it? One way we can simplify this is with long division. So you could divide this into this, but I'll take a shortcut, because another way to do it, and you'll get the same answer, is you could just write down what the first 3 terms are. So what's the first term? It's a, and the second one? A or, and then the third one is a or squared. You know, so you could do it both ways, but I'm not sure, does it really matter? No, do you know what? Actually, do you know what? I think the easiest thing to do would just be, believe it or not, leave it the way it is. So the next question is, how do I combine these two? So dividing's not going to work, because it's not going to what am I saying? No, dividing would work here because it cancelled the a. Or if you like, you can think about it as a substitution. You could get a on the left and sub it in on the right. You have a couple of choices here. Yeah. What would be the easiest way to do it? Let's see. I will need to do that eventually, yes, that too. I think I'll just say A is 256 over or power 8 and sub that in there. Yeah. So I get 256 over or power 8 times 1 minus or cubed over 1 minus or. That's equal to 3. Now I want to rearrange this a little bit. 3 goes into 256, doesn't it?
Yeah.
How many times? It doesn't go in? No problem. It doesn't go in, yeah? Okay. That's 3 or power 8 over 256. I'm thinking. I don't like the or 8. It's really not nice. Oh well, that's life, I suppose. Okay, let's continue. Not much I can do about it. Oh. Why did I make this so hard? Right, I want all the numbers on one side at least and the or's on the other side, so let's at least do that. So sorry, I'll just go back. 1 minus or cubed over 1 minus or, and then here there's a 1 over or 8, and this is a 3, and this is 256. Yeah, I think earlier I said I didn't want to long divide here, but I think I will now to simplify this. There's nothing else I can do. So I won't do the long division, I'll just go straight to the answer. When you do the long division, this piece here becomes 1 plus or squared. We've done lots of long division examples, so you can just accept that that's going to be right. 1 plus or squared over or 8 equals 3 over 256. So you can change this into 1 plus or squared over or 8 equals 1 plus 1 plus 1 over 3 power 8. So, can anyone see what the answer is now that I've done that? Or to be even clearer, I could change the number 3 into 1 plus 1 squared. And I can change the number 256 into...
How can a common ratio become...
Oh, sorry, yeah, I screwed that up. I screwed that up. In the words of Trump Bigley. You're right, it's not 1, sorry. Watch carefully. I need a way to rewrite 3 and 256. I have it now, sorry. It's 256 is minus 2 power 8. Isn't it? Okay. And then I can say 1 plus minus 2 plus minus 2 squared. Yeah, okay, that was not easy. And the or is equal to minus 2. Oh, that was very hard. Very, very hard. Very, very hard. Don't worry, it'll never be that difficult in the exam. Yeah?
It's just like 256 is 2a squared, 8 times, right?
256 is, yeah,
Yes.
minus 2 power 8.
No, it's 2 power 8.
Well, it's or 2 power 8.
But,
Yeah.
let's say if a is equal to like 2 over r 8 times. 8 times? No, totally 8 times.
Huh? Say that again. A
Yeah, a is equal to 2 over r
power.
power 8. Yeah,
Where'd you get that from? Oh, from here.
yeah.
Oh, I
And
see.
then- And then you said that S3 is a plus ar plus ar squared.
Yes.
So you just put it, yeah, you will find this easy. Just put it.
Maybe slightly easier. Yes. Yeah.
You know, it eliminates, you know, the times eliminated because RA is under 2, so A will become 6.
You're saying A
7,
plus
6 become 2.
AR plus AR squared,
Yeah.
and sub that in.
Yeah.
You think that's a little easier?
Yeah.
Really?
Yeah.
Okay.
It's
Maybe easier for you.
so bad.
Easier than this?
So easy.
So easy. Okay. I think that works because the 256 is a 2 power 8. Yeah. Which it obviously.
Because it's constant.
Yeah.
It's integral because we can.
Yeah. Yeah. But I don't think for every question it'd be like that. Yeah. For this one here, the 256 had a power 8. But I don't think it's always like that. So it works nicely for this one.
Yes.
Yeah.
Just for those.
Just for these types. Yeah. Yeah.
Minus 2 to the power 8 is minus 256.
No, it's not. Did you say yes? It is. Minus 2 power 8 is definitely 256. What has he forgot to do on his calculator? He forgot the brackets, didn't he? Yeah, okay. Right, moving on, last example. The last one is like the last one for the previous lesson. I tell you that 2x plus 2, 4x minus 8, and 8x plus 2 is GP. So I think some of you have an idea already to find the x.
B squared equals
Ah, no. Thank you. 4x minus 8 divided by 2x plus 2 equals 8x plus 2 over 4x minus 8.
is the same.
Yeah, I know it's the same. Okay. Let's solve this now. What should I do first in solving this? No, cross multiply. So I get 4x minus 8 times 4x minus 8 equals 8x plus 2 times 2x plus 2. 16x squared minus 64x, is it? Plus 64, is that right? Yeah. Equals 16x squared, and then 4 and 16, 20x plus 4
Yeah.
is right? Yeah. Cancel. 84x equals 60. So x is 60 over 84, which is 30 over 42, which is 15 over 21. Oh, they can divide by 3, can't they? 5 over 7. Yeah, so x is 5 over 7 is the answer. Okay, there's 10 minutes left. So the same deal as before. 1a, 2a, 3a, 4a, 5a, 6a, 7a, 8a, 9a.